So hello everyone, and welcome to this BFW 2401. This is workshop 8, and we are going to cover the rest of the credit risk. Before we start, we will talk a little bit about the test, the structure of the test that is coming next week. I will upload also a video, explanatory video in a while, maybe this weekend or maybe by tomorrow, and also the old test and all these issues. And if you allow me now to share, let me just share my screen. If you have any questions about the test, this is since next week is almost going to be like a break. You can ask me now if you have any question about the test, anything top of your mind. Later on, we will talk about it in a video. So this is the test. It will be next Tuesday, and it is 11:30. We'll start 11:30. I think what you need to see is like this. We are testing all these three chapters, 3 weeks, which is liquidity and liability. And I think I will decide, this is what I have planned, to have 8 questions. I think you have the test. I'll just, try to edit it again and try to, but I think according to my calculation, it will be 8. Something like 10, maybe I will increase or decrease 1 question here and there. And then we'll have spin questions for the sorry, this is capital single on risk, and this is portfolio risk, which is actually week 8. So, and then this is the materials. I wish you can look at it. We will have 2 old tests. I want you to look at them. In the explanatory video, I will explain what are the things that you are not required to do. For example, in week 6, I think you can ignore part 3 and 4 of the lecture slides. Actually, the recording of week 3 and 4, the recording of part 3 and 4, because we have only 1 slide, but you can ignore it. You can ignore that one, and they will show you exactly what I mean. But if you look at the recording, you will see where we started part 3 and 4. I just want you to be aware of one of all those. I think there is 1 slide about the trade-off of funding cost versus funding risk. In week 7, in single loan, this is the financial products. You can ignore them. And then in week 8, I think in week 8, I will test you on the derivatives, because we talked yesterday about the derivatives. We have around 6 type of derivatives, some of them options, some of them forward contracts, and this is to manage the credit risk. I don't think I want, because it's only, there is no calculation about the payoffs of those options, and the structure of the derivatives are not also included. So I will ignore it. So you can ignore it in the test. When you reach to that area, just ignore it. Again, I will explain this also in the I will explain it on the explanatory video. That's all. Now I can move actually to the workshop, unless there is any question you want to ask me now. It will be good. Any question, guys? Oh, very quiet people. Either you understand everything or you just waiting. Anyway, regardless whether you have questions or no, you can always email me. It's just because we are not going to meet next week. We'll just meet for the test. I wanted you to know it from now. Okay. Now, if there is no question, as I can see, there is no chat, there is nothing. I just want to ask this question. How many of you, because I will adopt my, how many of you, please go to Poll Everywhere. I have just survey, small survey. I want to know how many of you are will take their tutorial tomorrow. Or just, you know what, I don't need to do a survey. Just please wave to me how many people are taking the tutorial 8 tomorrow, because I already covered the tutorial in the classes that happened during the last 2 days. Some of the problems are related and some of the concepts. Yeah, so we have Carl. Please wave to me or raise your hand, students who are going to take the test. We'll cover their. Okay, don't see many of them. Okay. Then. Okay, thank you very much. Then let me share, because I have covered some of those ideas yesterday. If you are, before I start, I already uploaded for you the solution of the workshop in Moodle. Please download it and we can go step by step while we are doing this workshop. Please download it. It's already in Moodle. I just uploaded for you now. Please tell me if you cannot find it, but I already uploaded for you. Yeah. Okay. I'm sharing now on my second. So I have some, I just shared now on my other device because I want to write some of the things. So okay, this is what we are going to talk about. And you can look at the first question. So I divided the workshop in a way that, can you see my screen, right? You can see my screen now, yeah. I divided this workshop in a way that, that goes over those credit models, which we cover in week 7 and week 8. Some of them coming from week 7, maybe just for the, because we didn't include it in the last workshop. and mostly from week 8. So probability of default of multivariate data instruments, this is the first multiple choice question, and I brought it here because we are going to do what you call some calculations. So it's, if you look at the answer of this one, it's the cumulative. If you see this question in the test, whatever, it is a cumulative default probability. This is how we define the cumulative default probability, because it's over year 1 and over than more than 1 year. So when we are calculating, as I told you, when we have, this is the years, and this is year 1, year 2, year 3, and this is, for example, the I and K for year 1, I and K for year 2, and I3 and K3. I can know now P1 is actually 1 plus I over 1 plus K, which means to get the probability of payment for year 1. But if we are talking about cumulative, now we want actually, if this is year 1, year 2, and year 3, we want to take this loan that will be, we are giving a loan of 3 years, then in this case, we want to see the defaulting of year 1 and the defaulting of year 2 and the defaulting of year 3. And when we say that, that means we have to calculate B1 and B2 and B3. B1 and B2 and B3. So this is the 2, and this is the 3, 1 plus I, 3, 1 plus K3. And when we are going to calculate the, what you call cumulative, then we have to calculate the cumulative in this case, just to answer this multiple choice question, the cumulative probability of year 3 will be 1 minus probability payment of year 1, year 2, and year 3. This is what we are trying to get. This is what we mean by the cumulative default probability. And this is how we calculate it. So to come to the calculation, this is why I was asking how many of you are, I explained this it's one of the problems in the tutorial today and the workshop today, but also it was a question in the tutorial yesterday and for the tutorial that will be taken tomorrow. And yesterday we just talked about the 2 years. Now we are talking yesterday in the tutorial we have only 2 years. Here we have 3 years. And I think I have explained in my tutorial the issue. I want to repeat it here for people. So if I'm repetitive for some of my students, please allow me to do that, because a lot of people will hear maybe this explanation later on or for the final or whatever, and also for the students who are going to take it tomorrow. So if we are talking about as I said, if this is the graph, we are talking from the perspective of, we want to calculate this. We already know, because when we have prices, we have what we call spot. And spot means I can give you now a rate today. If you are a short-term investor, I can give you a rate for 1 year. If you are a long-term investor, I can give you a rate of 2 years or even 3 years. which means in this case, for 1 year, it will only be 1 year. If it is for 2 years and 3 years, then I will give you a rate. For example, if for 1 year, I will give you 6%, I will give you here 6% for 1 year. And if it is for 2 years, I will give you actually same, for example, 7% and 7%. If it is for 3 years, so here, for example, the 2 years spot is 6.1. If you look at this one, if you want to look at it, if you want to translate this here, what we have in the tables. So in the short term, spot for 1 year, and we are talking about treasury, we can talk about treasury, and I will give you 5%. For 2 years, as you can see, I will give you 6.1%. And for 3 years, which means this one and this one, 6.1, 6.1. Now, as we negotiate, and for 3 years, I can give you this one, which is 7%. Now you can repeat this. You can repeat this, and you can repeat for the Triple B, which is the group rate. This is the treasury, which is the free risk. The point is, if we want to calculate the probability, we have to calculate the actual or the forecasted, the accurate forecasted probability of payments for year 2, year 1, and year 2 and year 3. And it's in order to get the cumulative probability of defaulting over 3 years. Now, the issue is I have the spot for 1 year, I have the spot for 2 years, but if I'm going to, and I have the spot for 3 years, I don't have the forward. This is the forward. For example, for year 2, I don't have the forward for, this is the forward for forward 1 for year 2. And I don't have also the forward for forward 2, and it will be in year 3. Because if I have them, if I have this, I can divide the forward over the, what I have calculated, the forward over the, I can get the I2 and K2. Now the forward for, if we are talking about the treasury strip, the forward for forward 1 for year 2 is actually this one. And forward is actually this one. Now I can do the same. I'm now trying to get for I can try to do the same for K, and my problem is solved. So I can get actually the 3 Ks. And if I get the 3 Ks, I can get the 3 Bs. And then I can calculate the cumulative. So the assumption here is that if we have free arbitraging, and when we said free arbitraging, if this is the long term and this is, I cannot play between short-term investment and long-term investment and make a profit. I can, by shifting from here to here or from here to here, as an investor in my investment horizons, I will not make any profit, which means whether I take year 1 and then liquidate here, and then take my money and invest it for the second year, and liquidate here and invest for the 3 years, it will be give me the same for this one. Whether I use this way, if I am an investor of 3 years, whether I use this way or I use this way, I will get the same thing. Now, if we are talking about 3 years, if we are talking about the 2 years, it will be the same. And therefore, I can calculate now, if we agree that there is no probability, there is free arbitrage and we cannot make profit, then in this case, actually, if we are talking about this short term of 1 year, which I know, and the one I don't know, this is F1 year 2, which is forward for year 1. And this is I already know, which is the 5%. Now, I know this and this to be 6.1% and 6.1%. Then I can actually calculate what we call I can make this equality, which is actually 1 plus 6.1%, which equals this and this, which is 1 plus 5%, and then times for year 2. And if I know this, I can actually calculate, which will be I can just solve for the F1(2), which is for the forward of the first year, for the first forward, which will be happening in the next year. I can get this one, which is 1 plus 5%, and I can get it to be, as you can see, we get it here to be 98.13. So I can get it to be 721. Now I gave you just this example. Now we can continue with this. I will not explain it all, but this is the whole idea. If I want to get the 3 years, which we didn't cover in the tutorial, for the 3 years, I will have the same thing. I will have 1, because for the 3 years, I will have this equality, which is 1 plus, for the 3 years, it's 7%, right? It's 7%. So it will be 1 plus 7% to the power of 3. Then this will equal actually 1 plus 6.5% square. Then 1 plus forward. And then I can solve for the, because I'm taking now the in this issue, I'm taking here now the 2 years, the 3 years, and I'm taking the 2 years plus the forward for the 3rd year, which means I'm making the equality of, I have this one, I know it's, if I'm talking about the 3 years, I have the equality, which is now here 6.1%, 6.1%, And for the third year, I know it's 7%, 7%, and 7%. I'm just trying to get this one, which is forward 2 for year 3. And I get it by here. You can solve now for the F2, 3 and get the number. And in this case, if I have all the forward rates, I can calculate now the probability of payments. I will do that for the treasury strip, and I will do it for the corporate rates. And in this case, I can calculate actually forward year 1 for the treasury securities, forward year 1 for the group rates, and then I can calculate also for the forward rate, second forward rate for year 3, which belongs to the treasury, and forward 2 for year 3 for the triple B. And when I reach this position now, I am really able to calculate B1, probability of payment for year 1, probability of payment for year 2, probability of payment for year 3 from those numbers. They are ready. For example, for year 1, I don't have to do too much things because it's only this one over this one. But for year 2, I will get it from the forwards, this one, and this one. And for year 3, I will get this one and this one. And in this case, I can calculate the probability of payment for year 1, year 2, and year 3. And when we calculate the probabilities now, the cumulative probability. So for B, for year 2, I can get it to be 3.84. This is the defaulting we expect over 2 years, which means if you take if you want the probability of payment, which will be 1 minus 3.84. This is the probability of payment, which is 96.16. And for year 3, the cumulative defaulting of 3 years, 6.18, which means now if I want to calculate the probability of payment over 3 years, it will be 1 minus 6.18, or I think 93.84, if I'm not mistaken. That's all. The difference I did here, the difference I did today is actually which is different from the tutorial, is I used 3 years. Now, in the test, I can give you even 4 years or 3 years. It's the same, approach. There is nothing more or less. Now, if we are done, is there any question, or do you want me to wait? Is there any question before I move to the next issue? Are we okay? Okay, I assume everything is just okay. My students are very quiet today. Nobody's telling me anything. But please exercise those ones, and it will be okay. Now, the second question also, it's very important. Carl, you are raising your hand. Do you want to? Is there any question? Oh, okay. If there is any question, just chat. Now, the second question, which we talk about the LORAC, we discussed also the LORAC in my tutorial is today, and Ovian will discuss it with you guys tomorrow. And it's the same thing. However, the thing I added here today is some other things. I added, yesterday we just straightforward, we calculate the LORAC and we take a decision to accept or reject the loan. Now the LORAC, as I explained before, is doing two things, just to refresh your memory. One thing is it goes in two steps. And LORAC, as we said, it's a type of a credit scoring model for single loans. However, it does for us two things. It helps me select the right customer, the right borrower, and it helps me price my loan, which means how much I'm going to charge that borrower based on his risk. So it helps me calculate the premium, and also it helps me select or credit score the borrower. So first of all, I have to calculate the LORAC, which is the risk-adjusted rate of capital. And this can be through the following thing. I have to take any additional income. Remember, when we talk about, as we said yesterday, when we talk about the LORAC and we want to see how much we are going to charge the customer, we don't calculate something like the ROA of the loan, which means we don't take the interest and divide it by the loan. And we say, well, this is a percentage of our return. No, in the LORAC, we take anything which is only the spread. And the spread means I already know how much is government securities is giving me. I need the K. So the difference between the government securities and what I'm going to charge, called the premium. I need this premium, or we call it spread sometimes. So I need to calculate I think I need to calculate the spread and the fees. And these fees has to be every year. This is actually, we are not calculating the interest, the whole interest, but the additional income that will be created when I give this loan, which means the marginal income. Not everything. If I'm going to do that, I need to take the additional income over the additional risk, which is actually what we call the risk or marginal risk. A marginal risk and the marginal risk, we measure it according to something called the change of the value of the loan. And we have a formula called, we borrow it from durations. So we take the duration of the loan, how long it will continue with us, times the loan itself, times the most important thing, the change in R over 1 plus R. Now, if we know this, so this is fees plus spread. And this is actually the risk, which can be found through this formula. Change in R. And this is the change in R over 1 plus R. So if we are done with this, and this is we already know, look at this problem. I can actually calculate very fast because do I have the fees? I want to see because I need now the fees, I need the spread, I need the risks. So for the loan, it's 5 million. This is one issue we need. I highlighted for you. And then the servicing fee is actually 50 basis points. So I will do it like this. So the fees is 50 basis point. The loan is 5 million. What else we have? We have the duration, 7.5 years. We don't take the maturity of the loan. This one, you don't take it. You take the duration. The cost of fund of the LORAC of 10%, which means it costs me 10% for the funds, and I give it for 12%. So actually I have 2%. I can add it here, which is the spread. Now the spread is 2%. So total actually I have now 2.5%. This is, which is the fees and the spread. You can have it times the 5 million and you are done with the denominator. Now I need only the, to calculate this area, which is the risk. So I have the loan, I have the change in the loan, the duration of the loan. This is the duration of the loan. And what else I have? I have the change in R, which is actually 4.2%. And I have the R, which is 12%. So I am ready now to calculate this area, which is, if you want to calculate it now, it is actually duration of the loan 7.5 times the loan, which is 5 million, times the change in R, which is 4.2%, over 1 plus 12%. And what about this is the denominator? And this could be 2.5% times the 5 million, which can be 125,000. I get the LORAC now, which is step 1. Now, step 2, I have to compare the LORAC to the ROE and accept or reject. So we did the calculation here, and I think we did it in the tutorial. So I'm just transferring this, for example, this area 2.5%, which we call 125,000. We have the expected interest. This is what we will charge, and this is what we will pay. So this is the plus, this is the minus, and I have to plus also the fees. If you take them all, you will get the same number, 125,000. And if you do this calculation also, it is here. And therefore, I can calculate the LORAC, which is step 1, calculate it, and find it 8.89%. And then I have to decide whether to accept it or reject it, as we said. And because the LORAC, the ROE it's mentioned here clearly. The LORAC benchmark is 10%. So this is actually less than the 10%. So will be rejected. So as you can see, I calculate the LORAC, and this is step 1, I find it here. And this step 2, I compare it to the 8.89%, compare it whether it has to be more than the ROE, but this is less than the ROE. So this is step 2. You can make it like this. Better to make it like this. So step 1 is this one, and this is step 2, which is you compare. If it is less than the ROE, you reject. So reject. Now this we understand from the tutorial. And we said for this customer, please leave. It's not please leave, we just say, we don't think we can continue with you. We cannot give you the loan. But there is always negotiations. There is always negotiations, and you have to do some negotiations. And what I have increased here is I say, okay, actually I can change the LORAC. If the LORAC is this divided by this, then actually I can play. I can play with this area, or I can play with this area. Where is the area which I can play here? I can just tell him, give me more. Give me more fees, give me more spread. I can change the LORAC. I can make it, if I am willing to increase this LORAC, the only way to do it is to increase this amount or decrease this amount. So what is increasing this amount means? Increasing the income, which means there is a room actually to negotiate with the customer to tell him increase the income. The question is how much? So if we decide to go to step 1 and discuss the increase of the fees in order not to reject this loan, we can tell them, okay, how much you should increase, and I can play it from this formula. So the LORAC actually, as you can see, is the income over the risk, right? And this should be, I need 10%. And the income now, I want to know how much to accept it. And the risk, I already know it's, which I calculated already here, 1,406,205. Excuse me, 250. To solve for the income, I found the income to be 140,000. It's this one. So if I increase the income and I solve for the income, as I told you, the LORAC equals income plus risk, and I find it to be 1,4. This is the income I should have as a fees and as a spread, 140 to 625. How much they are paying us? They are paying us now 125. So if I can convince the customer to increase 15,625 as fees or as interest, I can choose. then I can accept this loan. Then I can accept this loan. It's actually equals to the LORAC. But I needed to, if we increase it to this amount, we can accept it. Now let's move. If there is no room to increase the income, there is no room to increase the income, and the customer did not accept this approach of discussing, we can tell them, okay, we can play with the denominator, which means we can tell them to increase, we can play with decreasing the risk. And how we can decrease the risk? As you can see, if the LORAC still $125, but then the risk, I will only change the timing, which means how long they will pay us, which means I need to play with this number. If I tell him, can you pay me faster? The duration of this loan is 7.5 years. Can you pay it in less than 7.5 years? And if he said how long, then in this case, I can tell him how many years. So in this case, I can solve for that actually. And I can solve it by this formula. See, I will do the same equality. And then I will take the change in the loan. This I will make it, I will solve for it as we did here. So I will take the 125 denominator, and the numerator will be the duration. I will solve for it. And then I have the 5 million as it is. And then I have the 4.2 over 1 plus 12. Okay. And in this case, I can solve for the duration. And the duration shows to be 6.67 years. So this guy was going to pay me 7.5 years, but if I decrease it and I tell him to pay me in 6.67 years, which means 8 months. But at least we calculated now 6.67 years, I can accept this loan. Also, the LORAC was rejecting it, but I can play with the risk. The other thing also, I can play, so we played with the income, and we can play with the duration, and we can play with the, and this is internal thing, we can play with the spread, which means if this customer, if I'm considering 4.2%, to what extent I can decrease this and decrease the spread that I'm looking for, and decrease the change in the interest rate, which is the change in R. Now I'm assuming the change in the interest rate according to this 4.2%. But if I solve for it and make it there, if I can accept 3.73% as risk for this customer, then I can give him the, then I can accept the loan. And if we can calculate now according to this one, I can accept the loan. So this is the issues that the LORAC will discuss if you want to decrease or increase. If you want to decrease or increase the, if the loan was actually rejected from the beginning, this was a reject,
And if there is a question now to play with that, which means try to make it accepted, then you can play with the income or the risk of the loan. And the risk of the loan, you can do it through the duration, or you can do it, duration means you pay, discuss with the customer if he can pay faster, or you can play with the decreasing the risk of the customer or the borrower to pay you faster. So actually, this is the core of the most important thing I want to discuss, because this has been a question in the final, actually. This is the other, sides or arguments of the LORAC. Now, if we are done, any question before I move to the next? Okay. Now we move to something called mortality rate deviation of credit risk. I have some bull everywhere. I will play it later on. But the question here, which of the following is true about the marginal mortality? As you can see, we have all those marginal mortality rate is one of the single loan models, which is this one. So the way we do it is, if we are going to invest and we want to decide in our investments, we can take the marginal, what we call mortality rate, as an indication. So if you look at this graph, this is a bond that we are going to invest. Maybe it's a class of bonds this is for B bonds. We have mini rating B bonds. And this in B bonds, the bonds of course goes for 30 years, but and this is a published data, they publish it always. They will tell you what is the, how much of this class was defaulting in year 1, how much was defaulting in year 2, how much defaulting in year 3, how much defaulting in year 4, how much defaulting in year 5. As you can see, when we calculate the defaulting in year 1, we will take the total value of the bonds defaulted in year 1 over the total issues. So total value grade B bond defaulted in year 1 over the total issues of year 1 for all those bonds in this class, and you can see how much is the percentage of defaulting. And we can have for year 2, year 3. Now, as you can see, if we are talking about AAA, AAA will be less defaulting. So we accept this to be like this. Maybe 0. Maybe the curve will be very, it's not, very flat. But if we are talking about C, this is B, for example. This is C. If we are talking about another class like C, I think we will see it more steeper, which means the defaulting is higher. In year 2 is higher, in year 3. But for class, this is class A, AAA, for example. And maybe this is C. This is how it works. This is, so if you are going to invest and you want to see the credit risk where you are going to invest, then in this case you can look, or you are going to give a loan for one of those companies in these classes. This model can help you how much those people default, and it depends on your appetite for the risk, which one you will take, whether you will invest with a company that is CCC or B or AAA. But this will tell you, and they publish it. See, in the US, they publish it. They tell you the marginal and they tell you the cumulative for AAA. We were talking about B, right? But they can tell you, give you about B, A, or the classes according to the rating. and they will tell you this is the years. See, this is for 10 years. You can see it makes a lot of sense. Travel A, there is no defaulting. The first defaulting in year 5. But this guy, for example, Travel C, almost on the first year, 7.8 cents already defaulting. So this is some of the things that you have to understand about the mortality rate deviation of credit risk. This is the table and this is the graph, how it works. Now, coming back to the question, when we say which of the following is statement is true about marginal mortality, marginal mortality rate is the historic default rate experience of a bond or a loan. It's not a bond of a loan. It's actually marginal mortality rate is the probability of a bond or a loan defaulting in any given year of the issue. The problem with number 1, they didn't specify not specified in multi-year period. They are just talking about marginal mortality rate is the historical default rate experience of a bond or a loan. Number 2, the mortality B, the mortality rate is the probability of a bond or loan defaulting over a specific. This is not true, of course, it's not for specific. D, marginal mortality rate is the probability of a bond or a loan defaulting over specified multi-period period. This is not, it's just the question is between A and C. This is historical, this is the probability. So when we are going to invest, we don't, marginal mortality will give us the probability of the future investing of Travel B. Yes, it's historic. This data is historic data, but it will serve us as a probability. We don't need it as a historic. It just will give us indication if I'm going to invest in B, in A, what is the probability of defaulting? What is the probability of defaulting for C, B, and this is my, because I need information to use it as a future indication, and therefore when we talk about the marginal mortality rate, we are talking about a probability. It is a historical data, but it gives us a probability of the bond or loan defaulting over any given year issue in the future. So this is why we rejected A. Okay. Number 2, what is the mortality rate of a bond or a loan? What are some of the problems with using mortality? This is the problems. The problems is we use a time period, the number of bonds, and the sizes. If you look at this, because they are talking about, because the MMR, for example, marginal mortality for year 1, is the defaulting, right? How many of them? Over the whole issue, total issue of these bonds. Total issue, and this is the defaulting of this issue. Now, this is actually related because I'm taking a history. If I'm taking the 1970s, different from the 1980s, different from the 2000. So if I'm going to take any, it depends on the time period of taking those. It can be early, it can be during financial crisis, it can be after financial crisis, it can be, you know, so the time actually period of the taking it is a problem, and the number of bonds. So if the issue, if I'm going to take Travel C and there is only little number of bonds issued in that class, then in this case, it may give me not the right indication if we have so many of them in AAA. So when you compare the classes, it depends also on the number of bonds who are defaulting here. I can say C is better than A, or A is better than B, but it also depends on how many people, how many of them defaulted here, and what is the total issue. So if the issue actually is less in one of those ranks, the number of bonds will play a role. And also the size of the issue. So the number of bonds and also the issue and how big is the issues. So these actually are neglected in this model, and this is one of the weaknesses. So this is the problems with the MMR. This is a good practice, and I think it's very interesting. Look, I give you in the exam, in the test, and the workshop these numbers. So this is, we have two business loans and we have mortgage. Now in the business loan and the mortgage, coming back to the mortality, we have year one, we have year two. I'm just trying to reflect, simply I'm trying to reflect this table, this exercise, because you have marginal and you have cumulative. For AAA, and you have it for A, and you have it for A, B, and all those ones. So to do it, if I give you an exercise like this, and I tell you, let's talk about, for example, let's talk first about let's take the business. So the business, we have annual and cumulative. This is the business loan. So in year one, it's the annual default was 0, which means the cumulative default of this year is 0 for the year one. Then I know this is the annual default in year two. The cumulative for year two is 10%, means actually I have during that year 10%. Because the cumulative will be this, the cumulative of last year, plus the defaulting of this year will be the cumulative of the second year. If we take this logic, so we have here 10% as a cumulative, and we have a probably and defaulting of 50%, means this is actually 60%. And if I know this is 80%, which is the cumulative for the 3 years, and they want me to fill here, which is how much this year was, so it's actually 60 plus what to be 80. And if I want to know the cumulative for the third year, it will be this plus this, 1.10. Same thing when you haven't here. As you can see here, it's 10%. Now, how much is the cumulative for the second year? It will be this plus this, which is 35%. Then how much the cumulative for the third year? It will be 35 plus the cumulative of year. So this is what I have from year two, more cumulative, more defaulting in year three. So the cumulative defaulting in year three is actually 95%. And if I know this is 164%, which is a cumulative for year four, I want to know how much they default in year four, which is actually the difference between 95 and 164. So 95 How much is this, guys, huh? 95. So we have 5. Sorry, this is 69. This is 69. Why they make it 70? It looks like some rewinding, whatever. So 95 plus 5. This is 69. And then if I have this 164.80, I just can add it and to be 2.43%. It's not, this is basis point, huh? 2.3%. Okay. So this is actually already solved for you here. I just told you how much it works. So if I ask you a question now, what is the cumulative survival rate over 5 years, you will get the one minus the mortality, which means that defaulting in year 1, defaulting in year 2, defaulting in year 3, defaulting in year 4, defaulting in year 5. And in this case, according to this example, so if we are going to do the cumulative survival rate over for the business loans, it's 1 minus, this is for year 1, this is year 1, and year 2 we have 10%, and year 3 it's not 10%, 10 basis point, 50 basis point, 20 basis point, 30 basis points, and therefore survival is 98.9%, which is the 1 minus all the defaulting through those 5 years, which is you just take the years. Or you can say it's 1 minus this one, which becomes 98.9%. You can either take the cumulative, this is just telling me the cumulatives of the years, or you can just take the cumulative minus 1 and you will get the same number. Or you can do it this way. You can do this for business loans and you can do this mortgage loans. I think this is very straightforward. And okay, let's play a little bit, because these questions I brought them all in and pull everywhere. Please log in. Just give me a minute. Week 7. Let's play this one, please. Oh, you can. Can you participate, please? So we are using past data. When you use this is just to catch up some of the problems. So the probability models, we use past data, and this is what why past data? Because we are using the numbers of the financial report, which is actually historical data. Help me is here. Even is here. Linear probability model is 3 factors model. If you still remember, that calculate the probability of defaulting and its benchmark to accept or reject a loan. Is that right? Is it 3 linear probability? It is 3. Altman is 5. Linear probability is 3. LB is there. Yes, even guessed. Okay. The probability of z square, this is accept or reject. Oh, probability of defaulting according to the linear model is 3%. And the bank only grants loans that have 98%. So this guy actually will be rejected. So this loan will be accepted. It will not be accepted. It will be rejected because I needed to be only 2% probability of defaulting. My probability of accepting is 98%. This guy has a defaulting of 3% according to the model. So I will reject this loan. This is very straightforward question. I don't know why you missed it. This is according to the linear probability model, not the Altman. Oh, these guys, I think, were very careful. They think it's the Altman. This is just very straightforward. It is a scoring model. Logit model is one of the probability models. One of those models we have talked about. This is the Altman. Do we need forecasted financial data or do we use historical data? Forecasted means future data. This is the point. Do we use the financial statement? We don't use forecasted data. We use historical data because we use the balance sheet data, and balance sheet data is historical one. All these models use historical ones. I think you already guys forget things. A company with an ultimate score of 150 should not be granted a loan due to high default probability. Yes or wrong? This is very straightforward. You shouldn't miss it. The score should be over 299. Why you forget, guys? It should be more, less than 181. You don't accept. Between 181 and 299, you review. Over 299, you accept. So in this case, this loan should be not accepted because it's less than 181. Just a little bit review. This is from week 7. I just want to see how you are on that issue. 225, does it say what? If 181, less than 81, reject. Between 181 and 299, it's a consideration area. It's a consideration area. Ultimate Z of 225 indicate that it's difficult to predict whether. So it doesn't say this is what we call the critical area. So the answer is true. But over 299, it's no problem. Is this right? Yeah. Oh my God. Okay, mortality rates analyze historical default data, which we just finished now. Mortality rate analyze historic default risk experience of bonds and loans of similar quality. So we are investing in the same class, not actually the same. Yeah. It's true. It's true. So they are measuring the triple B, triple A, C. So if you are going to invest in one of those companies who are in these classes, then in this case, it's a similar one. It doesn't have to be the same one. They give you the full class and you may choose from these classes which company you want to take. You want to take one from the rating class of triple A, rating class of triple B. So this is what does it do? Because it do the classes, it do the whole class of those ones. So the defaulting is about the whole class. So if you are going to, you can take a company which belongs to that class, which means similar. It's very straightforward, it should be okay. We have talked about it so many times. Yes, thank you. Next one, okay. This may be difficult to you, but actually it is about the payoffs, yeah. We talked about it as, this is why we call it option. It is option, yeah. KMV credit monitor model compares loans with option payoffs. That is right. This is why we use the options from the perspective of the shareholders and from the perspective of the bank also. Guest 821. I haven't seen you this. I know the rest, but the guests, I don't know who they are. Okay, so I will stop share here and I will share here. It's now 1 o'clock. I want you just to look at, maybe I'll just take this, nothing more actually. This is the mortality, about the mortality, for example, the mortality here, when we talk about a borrower with a risk grade of 2, which is this one. This is about the immigration. This was 100% in this class beginning of the year. And this is what happened during the year. So for this one, during the year, it was almost 100% because this is A, this is class B, this is class C. So 100% they were there. Beginning of the year, they were 100%. During the year, 12% of them go to here, and 3% go to here, and 83 is still in the same class. So when you look for an investment and you are looking for those classes, then you will see the immigration. If the immigration going up to the high classes, which means this is good companies. If they were in AAA and they're going down to lower classes and to default, then it's not good. And therefore, when we look at here, if you want to understand the table, when they tell you a borrower with a risk grade of 2, in the beginning of the year, yes, has 3% probability of being downgraded to risk grade 3, which is right. This is real data, but it actually gives me, this is if I'm going to take one of those companies that is here, they have a probability. This is the behavior of a whole the class of A and the whole class of B and the whole class of C. If I want to invest in class of B, they will behave like the other, they are going to behave like the other bonds, which means there is a probability that they will drop to 3%. Of course, there is a probability that they will go with 12% to go to A. This is how we test this mortality. Concentration risk, I think we discussed it yesterday, but it is we have two problems here. For example, you have the concentration limit. Equals maximum loss of capital. This is the formula, times 1 over the loss rate. If we look at this is 12%. And this is 35%. I can calculate this, which is this formula. Same thing, if I play again and I told you now, actually the capital is 12%, still 12%. And I want to know the loss rate. So I give you this and I told you the concentration is 35%. And this 12%. So how much is the loss rate? And if you calculate the loss rate, it will be 34.29. This is just to, for modern portfolio theory, I will not ask you, modern portfolio theory, actually you calculate the weight, we can calculate the R, and we can calculate the standard deviation. We have two formulas, and I want you to look at this. This is how we calculate the R, which is the weights, and this is how we calculate the standard deviation. Now, for example, if we have loan 1, loan 2, loan 3, this is 100%. And they represent 15%, 55, 30%. And the rates of those bonds of the portfolio is 12.35, 10, and 15.75. I can get actually the average R or the R for the portfolio, which is actually, you just calculate this time this, this time this, this time this, and you add them up. And this is what I did. So the portfolio is 22, 12, 22. This is the return of the portfolio. This is straightforward for the R. When you do the standard deviation, it is the issue because you need to calculate for each portfolio the standard deviation and the return. And you have to put the portfolios in all these points and you choose this one. We call this investment frontier. So investment frontier, you put the portfolio that has the less standard deviation, and then you match it with the high return. This is the best portfolio structure for me. You have to start with the less, this is the risk, and this is the return. Take the less risk and match it with the high return, with the return, and this will be the best for you. You don't choose this one, you don't choose this one. So to do that, you have to calculate the R for each portfolio, and you have to calculate the standard deviation for each portfolio and put the portfolio here. For example, this portfolio could be here, and then calculate another portfolio, put it here, and then do the graph and choose this point. This is how we do it. Of course, computers do this for us because you build, you know, thousands and thousands of portfolios and you choose the best portfolio, unless you only choose 10 companies or, you know, 15 companies, but we are going to choose too many, then in this case, this is how the portfolio. Guys, I am done. I don't think I have any more question. It's just, we use derivatives for the, this is the last thing, and we can use loan securitization to manage, because here you sell the loan with its credit risk. And we can use also derivatives, which we have talked about before. Derivatives, which we have discussed. So securitization is another part to control credit risk. I will stop sharing here. The solution is with you. I hope, sir, may I have the attendance code? Yes. Melvin, I will come back to you. But let me get the attendance code for. This is the attendance code. Please take it and tell me if it is true or no. Melvin, you still there? He is asking how to get the 69%. It's the difference between the 69% here is the difference between the 95%, the 95 basis points, excuse me, and the 1.64%. So this is actually 69, if I'm not mistaken. $69 basis point. Yeah. Okay, guys. Is there any questions? I am here. I can stop share here. Thank you, guys. Thank you very much. Unless you have any questions, I'm here. Vivian? Okay. Okay, bye-bye.